Let's look at this example, which is the last-letter concatenation, which is simple for humans, but potentially complex for machine learning models, particularly if we are talking about training a model from scratch. So this task is easy for a human because we can naturally decompose this problem by identifying the last letters of the words and string them together. But why might the machine learning model need vast amounts of labeled data to accomplish this same task? Using models which generally require a large number of labeled examples to perform well. This is because most machine learning models, especially deep learning models, operate on patterns in the data and must learn those patterns from examples. So let's try to consider the machine learning process as we training a model from scratch. So for a machine learning model, to handle the last letter concatenation task, it would first need a dataset of many names paired with the correct last letter concatenations. For instance, if we input Elon Musk, the output is NK. If we input Bill Gates, the output is LS. And if we input Barack Obama, the output should be KA. So this model would then be trained by just processing many such pairs to recognize patterns in texts. For example, how to identify the last letter of each word. So a transformer-based model, for example, would use both encoding to understand the input string and decoding to generate the output string. So why does machine learning require large data? Even though this task seems simple, machine learning models doesn't inherently know the structure of names or words, but they need to learn from many examples before they can generalize. So training with thousands of examples can ensure that these models can handle edge cases like varying name lengths, different languages, and inconsistent input formatting. So transformers are designed to handle these very complicated tasks such as language translation or image recognition. So they benefit from huge amounts of data to capture the intricate relationships. So just by using transformers for these simple tasks, however, would be inefficient. In contrast, a human can figure out the rule for concatenating the last letters after seeing just one or two examples. This type of learning is more symbolic or rule-based. No depend on vast amounts of data. It relies on generalization from minimal examples rather than brute force pattern recognition. So this is symbolic approaches, which is why AI should learn with just few examples. So if an AI model were truly intelligent in this way, it would first observe an example or two, like input Elon Musk, output is NK, input Bill Gates, output is LS, and then it can abstract the rule, which will take the last letter of each word, and then it concatenate them, and then apply it generally to unseen inputs such as input Barack Obama, output is KA. So this is the neuro-symbolic approaches. This is where the neuro-symbolic AI comes to play. So in this neuro-symbolic AI, we combine symbolic reasoning, which is rule-based methods like human approaches, and with neural networks, which is pattern-based learning like transformers. So in this context of the last letter concatenation problem, a neuro-symbolic model might be. So we use symbolic reasoning to extract the last letters because this task is easily described by just simple rule, and we use the neural networks for more complex tasks like understanding and processing names in different formats or handling the variations in the input data. So this hybrid approach could drastically reduce the need for massive amounts of training data, while still allowing the system to generalize from just a very few examples. If a method Like the transformer, it requires huge amounts of label data to learn such a simple task. Does it qualify as AI? So AI as its standards for neural networks and deep learning often requires numerous data sets because it is based on static learning and it doesn't understand the tasks in like human-like way. Instead, it learns patterns from data. AI, as we might envision it, which is the intelligent models, should be able to learn with the minimal examples by abstracting rules like we humans do. So if a system can only solve problems after ingesting vast amounts of data, some would argue it is not truly intelligent. It is just a powerful tool for pattern recognition. In conclusion, while current machine learning models may need huge data sets for even the simplest tasks, but for more advanced models, especially those using symbolic reasoning or neurosymbolic methods, could handle this with just a few examples. So whether or not we consider these data-hungry models to be AI, which totally depends on how we define intelligence.